Hey everyone, welcome back to the Tensor Maker channel, where we explore and build on decentralized AI. Last time, we dove into what is Hypertensor and why decentralized AI is important. Today, we're taking a massive step forward. I'm going to show you how to run a Hypertensor node on testnet on your very own computer, and it'll take us less than 15 minutes. If you've ever wanted to contribute to decentralized AI, and maybe in the future earn tokens from doing so, this is the video for you. The third public Hypertensor testnet is live and available now, and probably for only a few more weeks. This is probably the last testnet before the mainnet launches, so we have a minimum time to learn how to run a node before mainnet launches to earn the maximum Tensor tokens. For those that are new here, I'm Steven. I've been working for 20 years in the tech industry, building networks from the early internet to modern data pipelines for AI. In our first video, I showed how Hypertensor flips the model of centralized, controlled, corporate AI on its head. No more gatekeeping by big data centers and companies. Now I'm going to show you exactly how easy it is to run a validator AI node on the Hypertensor network. Let's dive in. The internet and mobile networks have been around for decades, but normal people like you and I could never own part of that infrastructure. We just paid monthly fees for those services, or at best, built applications on top of those networks. With blockchains such as Hypertensor, we finally have a shot at being participants in these networks. You can now run a node, earn rewards, and shape the AI models that get deployed to these networks. Imagine contributing your CPU and your GPU to power these advanced AI models. In return, you get a share of Tensor tokens. It's kind of like hosting Bitcoin mining on your own computer back in the day. Except this time, you're fueling AI innovation, not just running hashing algorithms. In this video, I'll give you a step-by-step guide to make it super easy, even if you've never used terminal commands before. This will prepare you for the Hypertensor mainnet, and as I show you, it's not that hard to do. Let's jump into the setup. I run a Mac, but this can be done on any computer. And if you're interested in seeing how you can run a Hypertensor node on Windows, or in the future, I can show you how to run it in the cloud permanently all the time, let me know in the comments below. This is going to be a quick overview, but for full instructions, cut and paste style, please view the links in the description. The first one is the official Hypertensor documentation at docs.hypertensor.org. The second one is my personal GitHub gist, where I put cut and paste instructions that we'll be using today. Okay, here we go. You can see my desktop here. What we're going to do is we're going to follow this gist, these steps of commands that we're going to cut and paste from this guide that I created, and we're going to do it all on our computer. In my case, I'm running on a Mac. I'll show you in a future video how to do it on Windows. It's pretty much the same with some different commands. Now, we're going to be installing everything on the terminal, and we are going to be installing Homebrew to allow us to download the two most important packages. Git, where we need to get the software from the Hypertensor software down onto our computer. And second of all, we're going to have to download Python, the coding software that runs the Hypertensor software. So you can actually download them directly from Homebrew if you want to see. That's the official place to download. And here's the official Python download, but we're going to install everything through Homebrew, and I'm going to show you how to do that. First of all, we need to open a terminal. We just do Command space and type terminal, and it should launch a terminal window. And now we're literally going to cut and paste all these commands. Now I already have Homebrew installed. It'll ask you for your password, but as you see, it's already going to find it, and it's going to say, hey, I've already got this on here. And now we're just going to make sure with the next steps that we have the actual path installed. So here we go. We're just going to make sure that it's installed in our path so it knows about Homebrew and it can execute the Homebrew command, the brew command. So now we're just going to update the Homebrew software, and it's going to install Python 3.11. Now I'm installing 3.11 because I had trouble with some of the latest Python and then the libraries that are used by Hypertensor. I think it's at 3.13, but I decided to go back to 3.11 and everything works fine. So you can just double check that you've downloaded the right version, although it's already telling us that. And now we're going to install Git. Git is the public repository where Hypertensor is installed. So we want to install Git. to actually retrieve that software. Now we're just going to make a directory with this command and install the latest version for the Hypertensor testnet. Now it's called DSN. I believe that means decentralized subnet. This is what we're going to be building, a node on the decentralized subnet. So it's cloned it and it's put it on there. Now we want to set up a Python virtual environment. This sort of keeps all the packages that we need separately than your main system. So it puts like a little envelope around the Python and all the libraries that it needs to run Hypertensor. This way it keeps it all in one place, and if you want, you can delete it in the future and not ruin anything with your main environment. So now what we have to do is we have to create an environment for Hypertensor. Normally, when you run it, you're going to be funding it with a certain amount of tokens to register on the network. Right now, because it's testnet, there's no like associated tokens with money that you have to buy. And what they've done, the Hypertensor team has done, is they've set up a whole bunch of pre-seeded accounts that have already been there. Now, there's 1 to 100. So there's 100 different accounts. The problem is different people will have used them at different times. So I wrote a little mini script there that picks a random number between 1 and 100 and assigns that to your configuration file. So really this configuration file here is saying I'm going to use this account on the testnet, and these are the Hypertensor endpoints that we have to connect to add our node to the mesh. So here we go. Let's see what number it picks. So in this pick, it picked lucky number 7. So that writing in the file is going to be our version. Let's see if somebody's taken it. So there's another way you can actually do it, and we'll see if this one has already been taken, then we'll have to edit our .env, our environment file, and change that 7 to a number between 1 and 99. But let's see if we get lucky. So it gives you here on the script, on my documentation, an example environment file. So now we're going to install the Hypertensor package. So it's going to download all the different packages needed for Hypertensor that are described in that Hypertensor package that we downloaded. So it's downloading more stuff that it needs to run Hypertensor. Okay, it's downloaded everything now, and now we're going to generate a key pair. We need this key pair. It's like a public-private key. It sort of identifies your node on the network, and it has to be unique. So in the future, it'll be able to link that wallet or that set of funds with your node, so that it says it identifies who you are or who your node is. So we're going to generate a key now. And this should take a second. Okay, there. Now you see that it generated a private key and a public key. You need to save this key. This is the key that we're going to look at, this peer ID that we're going to need to register with the network. So now we take the next command, and now we're going to register our node with the network. But we're going to use the left arrow key back here. And we're going to take our peer ID, you can double click on it and copy it. And then down here, we're going to paste it in. And what this is saying is we're going to register our peer ID with our node that we're running. And the stake to be added, in this case, it's just 1,000. We're not really sure how much in the future you're going to need to register your node, but right now they're just leaving it as 1,000. It might not necessarily mean 1,000 tensor. It'll be a different version, and that's not really set yet. But this is just a sort of fake tensor to practice on the testnet. So now we're going to add this, and let's see what happens. Let's see if we can add ourselves into the network. Okay, so it looks like it added itself fine. Let me go back up. We should see something. Success. So we've added our node to the network. Now that we've been added to the network, we actually have to activate it. You might get an error that says, in this case, we got it okay, right? We see success. We actively, properly added ourselves to the network. But if you get this error that says intrinsic failed or extrinsic failed, it generally would mean in this case that that node has already tried to register and has already been used. What you have to do in that case is you have to remove the private key, and then you can run this script again to generate a new random number if you want, or you can go in and use an editor called nano. If you type nano and then .env, you can go in and manually edit and change that number to another number. And then you have to generate a new key pair and try again. Right? But in this case, it works, so that's great. So now we have to start the validator node. Now, in this case, we have to, we've registered it. Now we want to start the validator node up. We're going to run this command. And now what it's going to do is it's going to download this particular model, this AI model. This is like orangutan llama based on the Llama 3.1 open source model. and it's an uncensored version of it. So it should have a lot of the control and a lot of the censorship removed from it. And this means we're just going to run it locally, and then it's going to look for your private key, the one that was generated before. And so we're going to run this command now. In the first place, if you've never downloaded the model, this could take quite a while because it has to download chunks of that large model from the internet and then put it on your computer. But because I've already downloaded and tried this before, my computer should already have that model cached locally, so I don't have to re-download it again. So you can see now that it's looking for the network, it's running it, it's reporting how fast my node is running. It's not really running that fast, only at about 94 tokens per second. But you can see that it's sort of added itself into the network and into the blockchain. So I'm not eligible for consensus yet. That means I have added it to the network, but I haven't activated it. So now we have to go on to the next step. But you can see here in the documentation, I give an example of what you should be looking for if it's successful. And you can see now, before I activate it, I want to make sure it's fully loaded the chunks of that 8 billion open based on Llama AI model. So it's loading all the blocks. And then we should just wait here until we see, I think it says started at the very end. So let's just wait until the node is fully started, and then we'll activate it. So now you can see that it has started and it's been added to the network. Now we have to activate it to make sure it's actually part of that network, to activate our stake in the network. So what we're going to do is we're going to click on the terminal and then Command N and run a new one. You can move that down here. And we have to make sure that we activate our Python environment again to run the Python commands. So we're just going to make sure we're in the right directory where we downloaded the Hypertensor software. Now we just want to make sure that we've activated. Once again, we're on Python 3.11, so we've activated our Python environment. And now we're going to activate the node. So subnet ID 1, there's only one subnet on the testnet right now, and that's the one with that orangutan Llama 3.1 model. So here we are now going to activate, and here we go. So we got success, right? We've activated our node. So that's really cool. So now we've done everything we need to do from the command line, and we're going to go and check the status. So if we go to, let's open this in a new tab. This is the dashboard where we should be able to see all the nodes on the network. When you log into it, you should see all the nodes as part of our Hypertensor testnet network. And if you click on that little arrow here, you can see what version is being run. You can see how fast the throughput. So if you have a faster GPU, you should be processing more tokens. Tokens in AI are basically chunks of words in little groups, and that's how the AI takes them in and then runs the inference to give you back the answers. So some of them are running faster at almost 10,000 tokens per second, and some of them are not even running at 100. That's probably mine. Yep, and that's mine there. And you can see, you can check on it easily. So once again, if we go back and we find out our actual network that had joined, our peer address, if we go back up in here and look at our peer address that we used before, this is our peer ID. It ends in DOHCS. You can see DOHCS. So that is our node live on the Hypertensor testnet. And one of the things you'll see here is that it's a relay node. So I'll explain this in a future video, and we'll work on running a more permanent node always in the cloud. But relay basically means that I don't have my home firewall open and traffic can get out. I can reach the network, but the network can't come back and reach me in a full mesh node. So really what I'm doing is I'm communicating with a node in the mesh network and sort of hopping through them into the bigger mesh. And in this case, you wouldn't earn as many tokens, and it's probably not the best way to do it. So you have two options, either opening your firewall, so inbound connections can come from the Hypertensor network, or running it permanently in the cloud that has that bidirectional traffic. Okay, so let's go back here. We've got this running. If you want to keep it running, you have to keep, the terminal network open because now it's running. If I try to close these terminal windows now, my node will stop running and I'll have to start it again. If you keep your node down too often, the network will believe it's given up and you might have to wait several days before you can reconnect. But once again, this is just a trial just to see if we can actually get this working. So here I just explain how you can actually monitor it. We already talked about the dashboard. And then I explain a little bit about the connection mode. Now, if you want to test your validator, there's a simple chat that has been set up to allow you to chat with the Hypertensor network. So this is it. chat.hypertensor.org and you can say things like, what is TENSOR? And you can ask it, and it'll go out to the Hypertensor network, to this decentralized AI, and it'll find out, just like any ChatGPT or anything, it'll give you a response back after it processes it. So here we go. Hypertensor is a decentralized AI blockchain. You can read this. And the interesting thing is, it does tell you which node in that mesh processed it. So this one is KFLA. So if we go back to the dashboard and we look at KLFA, that's this guy here that processed that last comment, that last answer. Now, if we go back to the Hypertensor thing in here and say, why is decentralized AI important? We'll run it again. There we go. It promotes fairness, what we've talked about, fairness, transparency, and accessibility to all. Once again, the same node answered it. Now, this might be because you might be closer where you are geographically, or maybe that's the fastest node at the time. So it sort of routes the AI question and answer to the node that is actually performing better, whether it's how long it is to reach when it sends the requests or how fast it actually processes them with the GPU. So if we go back here, we can then, if we want to, remove our node from the network. So that's it. You've taken your Mac and you've turned it into a decentralized node for AI. And that was pretty simple, no? You're not just paying for someone else's compute, and soon you can be earning tokens and helping Hypertensor grow and become an unstoppable decentralized AI. Think of it as being an early internet service provider, except you can jump in right now, learn, and prepare for the Hypertensor mainnet. Thanks for hanging out today. If you found this video helpful or have any questions, please comment below. Like, subscribe, and pass it to anybody who wants to learn more about decentralized AI and how they can participate. Just remember, for a cut and paste guide, look at my GitHub link in the description below. For deeper details on how to run a Hypertensor blockchain node or a validator node, look at the Hypertensor official documentation below. If you'd like me to make a video on how to do this on Windows or how to run a permanent, long-lasting Hypertensor node in the cloud, please let me know in the comments below. And also, it'd be great to know if you were able to do this, or if you had any problems, also let me know. And finally, if you want to learn why decentralized AI is so important and how projects, open projects, such as Hypertensor, help solve some of these problems, watch this video up above. Thank you, and see you next time.